Hello students, good morning all of you. Myself, Krunal Patel. I am teaching in Shri Guru Krupa Vidya Sankul. Today our topic is Einstein photoelectric equation related to chapter number 11, dual nature of radiation and matter. See, as for simplicity, our topic is majorly imparted in two nature of radiation. Now, before going for radiation, I would like to introduce you some Einstein's theory related to Planck constant and work function. So, let's start with some basic definitions of this theory. See, Einstein already proposed that this scientist, as you see over here, Einstein is already proposed that wave nature of radiation. This is basic concept which was given by Einstein. So, let's start with this theory. There are some basic definitions over here. Number one, which is photon energy. So, imparted energy of any radiation is termed as photon energy. This is said to be definition of photon energy. If you are asked in your examination, what do you mean by photon energy? You should say that any imparted energy on a metal surface. You can add over here metal surface because we are imparted on metal surface only. So, imparted energy on metal surface is termed as photon energy. We would like to briefly notice this E over here. As you can see, energy always relates with Planck constant small h and frequency v. So, next topic, which is, let's say any radiation E on surface. You can see over here, I have drawn one figure to explain the whole phenomena. What should I say? Any radiation E on surface. See, I am here drawing one photon over here, which means the photon imparted on this metal surface. Here, as you can see, I am showing metal surface over here. This is said to be my metal surface. So, when any photon imparted on metal surface, minimum energy required to free electron. There are minimum energy which I have shown over here W0, capital W0, which is said to be minimum energy required to free the electron. In this theory, we would like to introduce one new term, which is work function. So, what do you mean by work function? Any radiation E on surface, minimum energy required to free the electron from metal surface is called work function. Which means if I would like to draw one electron from this surface, if I would like to free single electron, but that single electron must be first electron from this metal surface. So, it is necessity for any basic energy, any required amount of energy, which is said to be work function W0. Now, if you want to know what is the formula for work function, I would like to give you formula for work function which is associated with this energy only. But you can see over here small v, which is my imparted frequency. the frequency which I should use to produce electrons. So which is my imparted frequency. But here we should use V0, which is my threshold frequency. Threshold frequency. As you know, threshold frequency. If I am writing over here minimum energy required, so called work function. But if I am writing here V0, which is my threshold frequency, which term as minimum frequency required to free the electron. See, there are two things. Number one, minimum energy, which is work function. Number two, minimum frequency, which is threshold frequency. Both are considered in single equation, which is equation of work function W0 is equals to H into V0. Now further, Einstein suggests that any radiation exhibits wave nature, as I can say already over here. See, wave nature of radiation. Einstein is firmly proposed that radiation exhibits wave nature only. If I cannot claim that is true, we can say radiation can exhibit particle nature as well. So this Einstein photoelectric equation purely based on wave nature of radiation. This must be remembered throughout this theory, that we are learning about wave nature, which means radiation. And if you want to know, sir, what is radiation? So radiation, which means electromagnetic wave. As you see, wave nature always count with electromagnetic radiation. Now, let's prove this claim. You would like to prove this equation by using some assumptions and by using some formulas. If E is imparted energy, as you can see over here, E is my imparted energy of photon, W0 is my work function, यहाँ पे W0 which is my work function. So, see, total imparted energy will be converted into two different terms. Number one terms, which is my W0 work function, which means this work function minimum energy required to free the electron. So, if I would like to free one single electron from this given metal surface, I would like to convert this imparted photon energy into number one work function. So if let's consider one example over here. If I have total imparted energy, let's say total imparted energy as 100 joule. This is for just example. So if required work function is 10 joule, which means to free this single electron, we need only 10 joule energy over here. So where would rest of the 90 joule convert? So rest of the 90 joule is convert into kinetic energy of rest of the all electron which will going to emit from this surface. So see, total imparted energy capital E is equals to work function W0. Total imparted energy is equals to work function W0, which will be my first conversion. My second conversion would be Kmax. So let's suppose all the number of electrons lie on this metal surface. Let's say E. All the electrons lie on this metal surface. If rest of the 90 joule that I would like to use on behalf of this metal surface, all the electrons would gain small amount of energy. They will convert this energy into kinetic energy Kmax. So they will free this metal surface with highest amount of energy. So if I would like to write this Kmax, so as you know Kmax, which means formula of Kmax, which means half mv square, which means if rest of the energy 90 joule, as for our example 90 joule, that I would like to convert in each velocity of electron, so rest number of electrons will gain this energy Kmax. Now what is E? E, as I told you, E is my imparted energy, which is H into V. So here I do not give you a V. V is my imparted frequency, most important. There is confusion between V and V0. I am giving you some notations. V is my imparted frequency, V0 is my threshold frequency. V0 is my threshold frequency. As I told you before, threshold frequency, minimum frequency required to free the electron, and work function, minimum energy required to free the electron. So there are two frequencies over here. Number one, which is imparted frequency, number two, which is threshold frequency. Both frequency will be counted in Einstein equation. So this is not be the Einstein equation. Please do not get confused between these equation. This is just equation while we are imparting any energetic photon over the metal surface. So this may be considered as basic principal equation behind the Einstein equation. We would like to intercept this equation in our terms. Let's start. See, E is my H into V. H, what is H? As you already know, H is Planck constant. In this Einstein equation, we would like to determine Planck constant as well. This is further part of this theory, determination of Planck constant, as well as we would like to obtain work function W0. So now start with this theory and some practical applications. See, E is my HV. I would like to put up this value E of HV over here. I would like to put up this value HV0 of work function over here. Kmax will be as it is. So V0 threshold frequency, Kmax is equals to my E0. What do you mean by Kmax is equals to E0? So please pay your attention over here. Kmax, maximum kinetic energy, maximum kinetic energy required to stop highest energetic electron. From where this concept comes, I would like to say you, this concept comes from cathode ray discharge tube, previous topic of this chapter. Cathode ray discharge tube, you can see maximum kinetic energy required to stop the highest energetic electron, which is Kmax, and this value lies as EV0. So one of the most frequent terms of this chapter, which is capital V0, this is my stopping potential. This is my stopping potential. So if we implement this value in our equation, we will get E as HV, E as HV, work function as HV0, and Kmax. I told you before, we would not change this Kmax as it is. So put this HV0 in left hand side of this equation, we will get HV minus HV0 is equals to Kmax. Now if we can common this H from this both term, what we will get? H common, V minus V0 will be Kmax. You will surprise to see that this equation is known as Einstein photoelectric equation. This is known as Einstein. If you are asking in your examination, prove the Einstein photoelectric equation. Prove the Einstein photoelectric equation. Photoelectric equation. You should write till here. So, theory is not complete over here because some remaining terms over here. Number one, which is my Planck constant H. So, how can I obtain, how can I illustrate the Planck constant? So, I relate these both theory with a singular term, determination of Planck constant. See, we would like to find out this Planck constant from Einstein equation, and there is no any other way to find out Planck constant H. As you already know the Planck constant, I would like to write over here the Planck constant. See, Planck constant H is equals to 6.626 into 10 raised to minus 34 joule into second. This is basic value of Planck constant. So, how can we obtain this Planck constant? By using Einstein photoelectric equation. So, determination of Planck constant H V minus V0 is equals to K max. This equation comes from this. We are continue with our derivations. So, please pay attention. We are continue with our derivation. Theory is not complete over here. H V minus V0 is equals to K max. As I told you before, what do you mean by K max? K max, which means E into V0, E, which my charge 1.6 into minus 19 coulomb. V0 is my stopping potential. So, I would like to implement this value over here. H V minus V0 is equals to K max is equals to V0. Let's write K max is equals to E V0 charge stopping potential. So, what is our first purpose of this Planck constant? To obtain the value of H. Now, V0 is my stopping potential as you see over here. So, I would like to make V0 as subject. So, if I would like to make V0 as subject, the whole terms E will be down towards the denominator. So, H by E V minus V0 imparted frequency, threshold frequency. From this equation, we can easily obtain the value of H. Now, further I can simplify this equation. HV by E, V0 stopping potential. I had changed the sequence. My RHS now will be in my LHS. My LHS will be in my RHS. Stopping potential V0 is equals to C H into V divided by E. H into V divided by E minus H into V0 divided by E. H into V0 divided by E. So, please do not get confused between these three V's. Number one, imparted frequency. Number two, threshold frequency. These both are frequency, but these may not be frequency. As I told you, this is my stopping potential. I had already mentioned over here, V0 is my stopping potential. You can see over here. Called equation of slope. Now, we should do some mathematics over here. As you know, equation of slope, y is equals to mx plus c. What is the physical significance of this equation? You should know that y is equals to mx plus c, where my y is mathematical function, my x is also mathematical function, but m is my tan theta, my slope. M is my slope over here. So, if I would like to compare these both equations via functions, so my y My y is directly related with my capital V0 stopping potential. My x is directly proportional to V by E. Please pay your attention kindly. V0 is related with my y, V by E. Imparted frequency divided by E is my x. So where is my C? My C is H V0 divided by E is my C. So everyone must be confused with H by E. Sir, what should we do about H by E? I am telling you H by E is my major term to determine the Planck constant. See, M is my tan theta. So M is equals to tan theta is equals to H by E. This is said to be slope. So if anyone wants to obtain the value of slope, this is the mathematical representation of slope. What should we do with slope? Slope which is m and m which is my tan theta. So if anyone wants to obtain the value of slope for this Planck constant, what we can do? We can take common from this both term. What should be common? H by E. What will remain in this bracket? V minus V0. So H by E is equals to V minus V0 will go into denominator over this here. From this stopping potential, we will get H by E is equals to V0 divided by V minus V0. H, all the terms refer last time. H, this is my Planck constant. E, 1.619 coulomb. V0, stopping potential, imparted frequency, threshold frequency. So if you are given only imparted frequency and threshold frequency, and if you want to obtain Planck constant H, you must be given this operating voltage, which is my stopping potential. So this is basic concept how one can determine the Planck constant H. See, Einstein already suggests that the radiation exhibits only and only wave nature. But after some time, two brothers named Davison and Germer, both are exhibits particle nature of matter. So it will be further come with theory. As I told you, H over here is my Planck constant. Now the last term that we would like to obtain is work function W0. So how can we obtain work function? By this formula. Work function W0 is equals to H into V0. See, here I am giving you formula W0 is equals to H into V0. You should always know the graphical representation. I am giving you the graphical representation of this theory. See, this is my stopping potential and this is my frequency F. If this is my threshold frequency V0, and when you are imparting our energy of photon over here, this region must be not giving any electron, though this is blank region. Now electron starts from this point of view V0. Electron will emitted towards this V0, which is my threshold frequency. If we like to extend this V0 over the negative y-axis, let's say this is my O, this is my A. If this is my theta, in this case, this will be my theta, opposite vertical angle. So apply the tan theta over here. If you apply tan theta over here, which is OA divided by V0. Tan theta is my OA divided by V0. As I told you, this is value of V0. So tan theta, we already mentioned over here tan theta, which is H by E. So H by E, if E comes towards this denominator, H by E, which is tan theta, and tan theta which is OA by V0. So this is short method to obtain the work function. Work function W0 is equals to H into V0. If you would like to implement this value of H over here, what will be H? E into OA divided by V0. If we put this H over here, we will get work function W0 is equals to E into OA. What do you mean? Everyone notice here, this OA lies in negative y-axis. That's why I had to take negative sign over here in terms of theory, but not in terms of numericals. E, now E, which is 1.6 into 10 raised to minus 19 coulomb, OA, which is my perpendicular distance. So this is determination of work function, this is determination of Planck constant. These both are comes from this Einstein photoelectric equation. So today what we are learning? We are learning over here Einstein photoelectric equation, which is purely wave nature of radiation. After getting this wave nature of radiation, the scientist come de Broglie, which told about matter wave. The matter also exhibits two natures, which will be our further theory, which is de Broglie's equation or wave nature of matter. So I would like to give you some repetition over here. What we did any energy of photon imparted on metal surface. The first electron which emits from this metal surface, minimum energy required of work function W0. Now Einstein suggests the wave nature. I already told you wave nature. HV0, V0 is my threshold frequency. So imparted energy E will be converted into first work function plus Kmax, which is my maximum kinetic energy given to rest of the all electron which will going to emit from this metal surface. So just I give this equation over here. E is equals to V0 W0 plus Kmax, E HV W0 HV0 Kmax will be as it is. So this equation is briefly known as Einstein equation. From this equation, by some modification and the slope, we got Planck constant H and work function W0. This chapter based on some numericals related to these theories. First of all, we will get this equation E is equals to HV, where my V is C by lambda. I am writing over here V frequency, which is C by lambda. So E is equals to Hc by lambda. This is first equation which we will going to use in some numerical point of view. So we are completed with Planck constant and work function. Thank you so much.